Hi there. Today we're going to talk about the volume of a right solid. This is lesson 95. There's some vocabulary that you do need to know. The vocabulary on this particular one is, what is a right solid? A right solid is a geometric solid whose sides are perpendicular to the base. Perpendicular, of course, means up and down at a 90-degree angle. The area of the base multiplied by the height will give you the volume of that particular solid. I have drawn some examples of right solids that you probably have run into and would know, and I as best as you can, why don't you draw these in your notes. The volume of this rectangular prism, it's a right solid. Notice all the nice little right angles here. Okay, the volume is the length times width, which is of course this base, and you're going to multiply that times the height of this particular prism, which is here. Of course, it's here and here and here too. So you multiply it times the height. Often the formula for right solids is written simply as big B times H, which big B is the area of the base, and multiply that times whatever the height of that particular solid is, and then that will give you the volume. Here's another solid that's a right solid, and this happens to be a cube. We call it a right square prism in math world, but it's just a cube. All the sides are equal and all of the angles are right. Guess you can't get much more specific than that. Okay, and that again, if you take the area of this base right here and you multiply it times the height right here, you will have the cubic units, or the volume. This particular one on the left here, down at the bottom of my page, that's a right triangular prism. You can use either side, either triangle as your base. Okay, but you could use this as your base, and so you would have to use a formula for a triangle, which is base times height divided by 2, and then once you figured out the base, then you would multiply it times the height here. This would be your height. Okay, so this is your base, this would be your height, and it would give you the volume of that particular figure. This is a right cylinder. Right cylinder typically has a circle bottom and a circle top, and then to figure out what the height is, they draw a straight line, they plumb a straight line that intersects the base of the cylinder at a 90-degree angle. To figure out the volume of a right cylinder, you would have to find out what the area of the circle on the bottom was, or the base. Okay, and to figure that out, you must be told what the radius is at least, and of course then it would be the volume of a cylinder is big B times the height again, and of course this is going to be pi r squared, and then times the height, because pi r squared is the area of the circle, which is the base. Okay? All right. Now, there's just a couple of simple little things that would be kind of nice for you to know. All solids that are classified as right solids share a basic volume formula, which I've already shared with you. Volume equals big B times height. Big B is called the base, usually length times width, and then of course the height of whatever the figure is. Okay, when a cylinder comes in, if we're trying to find the volume of a cylinder, the area of the base is the area of a circle times the height of the cylinder itself. And again, we're talking about height figured as it's straight up and down through the center of the cylinder, and then we're hoping that they give us the radius. If they give us the diameter, that's no big deal. We can just cut it in half for the radius. So now these next figures are a little more complicated, and I don't necessarily think that you have to draw them in your notes, but in class when we talk about them, I am going to ask you to draw them. So this would be an easier way to do it. This is actually like a house. Okay, but the house is split into two parts. The bottom part right here, okay, that is a rectangular prism, and we know how to find the volume of a rectangular prism, okay? Length times width times the height, and that would give us our volume for our rectangular prism. Then we need the volume for the triangular prism. Here is our base right here, okay? And we have our two places where we have our base times our height. Height's right here, okay? This is our base times height divided by 2. And then multiply it times the height and the distance across the roof. Makes it a little more complicated. If you could take it apart physically and set it on the table, it would be so much easier. Here is your basic formula, and I'm going to blow that up just a little bit so you can see it. So the volume of the triangular prism, which was the rooftop, is 1/2 base times height, and this height is like height 2 because it is the height that goes across. And then for the rectangular prism, which is the bottom part of the house, length times width times height. The hardest part will be figuring out what to do with the roof. Okay? Now, always remember, take that back out, always remember that volume is cubic. Okay? So if you're finding the volume of steps, in this particular case, a lot of times you will, if you're like, let's say you're going to pour steps for your house and they're out of concrete, you'll have to draw yourself a plan. How are these steps going to be put together? It's all going to be solid concrete, and if so, you would have to find the volume of each of these separate pieces. So assuming that the top and the bottom are the same, which we would, if you were to find the volume of this first step, it would be 20 times 3, which would be 60, times the height, which is 15. Then this step would also be 20 times 3, but then it would be times 13. And this would be 20 times 3, but this one would just be times 7. This is a 7 here, okay? And so I've got the work down at the bottom, and it really probably would be to your advantage to maybe write this down, because I do believe there's a problem in the homework that's like this. So you have the tallest, 900, the middle, 780, and the smallest, 420. So it's 2,100 cubic feet. Okay, so that's feet cubed. Now, if you wanted to turn into that into cubic yards, you would have to set up a one of the railroad track conversions, and that isn't so hard, really. Okay, so I just wanted you to kind of see that. Okay, last thing we are going to do is I'm going to show you a challenge problem. And the challenge problem is a cylinder, okay? You are given 3 millimeters as the radius, and your given height is 10 millimeters. That's all you're given, and that's enough, okay? You need to draw the cylinder on your paper. You need to compute its volume. Remember, volume of a cylinder is going to be the area of the base, which is a circle, times the height. Okay? Now, an extra challenge that if you would like to earn just a little tiny bit extra points is take this cylinder, draw a net for it, and you remember what a net is. It's like you took it and you flattened it out, and then compute the surface area of the cylinder. Now, you have enough information to do that. Good luck. Have a great day, and I'll talk to you soon. Bye.